Okay, we're going to have a problem here with the population proportion. Well, there's your 1 out of 5. So in this problem, we want to know if more than 80% of customers who dine at the new restaurant would recommend that restaurant to a friend, or at least say they would recommend the restaurant to a friend. So we take a random sample of 150 customers, 125 of whom say they would recommend the restaurant. We've also got here, we use a 0.01 level of significance. So our hypothesis, again, reading the question, more than 80%, p greater than 0.8. Remember, this is a qualitative variable. Either they recommend the restaurant or they don't. So we're going to be dealing with proportion. And we want to know if we can conclude that more than 80% would recommend the restaurant. HO then is p equal to 0.8 or p less than or equal to 0.8. So all proportion problems are z-tests. So we're going to reject the null hypothesis if z-test is greater than 2.236. It's just a one-tailed test in O1. You can go to the z-table or to the very last row of the t-table where it says z-values. We'll compute the z-test, the statistic minus the hypothesized parameter over the standard error. So the statistic is p hat, that's 0.8333, minus the hypothesized proportion, that's 0.8. And here, I'll show you in a minute that calculation of the standard error, but here I just put in the formula itself, the square root of PHQH over N. So I'm going to emphasize that the standard error for hypothesis testing is based on the hypothesized proportion, in this case the 0.8 from the null hypothesis, not on the sample proportion. That'll be different when we get to confidence intervals, and we'll try and highlight that again then. But on the test statistic, we're using the hypothesized proportion 0.8. Well, anyway, you go ahead and do the calculations. You're going to get 1.02 for the z. This is what I was just saying a second ago. We're using the hypothesized population proportion to calculate standard error. So we're going to fail to reject HO. 1.02 is not greater than 2.326. And we're going to conclude that the proportion of customers who dine at the new restaurant, who then go on and say they would recommend the restaurant to a friend, may be less than or equal to 0.8. It's plausible. So the p-value approach, again, I've drawn the bell curve. We have the statistic p hat on the horizontal axis, also labeled as z-axis here. I have the hypothesized proportion of 0.8, that's the center of the distribution, and the standard error, sigma p, is equal to the square root of PHQH over N, and that all comes out to 0.0327. So we have our statistic, 0.8333, that's 125 divided by 150. We got that z-value of 1.02. Look that up in the table, you'll get a probability of 0.3461. Now that's going to be between the center, the 0.8, and the statistic, 0.83. And so that's going to leave a p-value in the tail of 0.1539. So now we're going to interpret the p-value. You can do this by simply reading the chart if you have it drawn correctly. If the population proportion is 0.8, that's what we have down at the bottom, then there is a 0.1539 or 15.39% chance of obtaining a sample proportion of 0.833 or greater. And notice that's what we have shaded in for the p-value, 0.8, a sample proportion of 0.8333 or greater. Okay, for a 98% confidence interval, we have the statistic plus or minus the margin of error. That's plus or minus the confidence coefficient times standard error. We're using the p hat and q hat because we don't have a specific hypothesis for type 2. We'll be able to use this to test a number of hypotheses. Anyway, it's 0.833. That's the sample proportion, plus or minus the z of 2.326. That's for a 98% confidence interval, times the standard error based on the sample proportion. And so we end up with 0.762 to 0.904. So I'll just repeat that again. We're not tied to a specific hypothesis, so we use the sample proportion to calculate standard error. So we're confident the population proportion is over 0.75? Yes, the entire interval is greater than 0.75. Are we confident that the population proportion is less than 0.9 or less than 90%? No, the interval includes 0.9.